Here comes the first question. Sand, silt and clay are collectively called as option A, soil separates, option B, soil fractions, option C, fine earth, option D, all of the above. So what is the answer? Answer is option D, all of the above. So sand, silt and clay are also known as soil separates, soil fractions, fine earth. Next question. Theory of clay particle was given by option A, Hillel, option B, Robinson, option C, Russell, option D, Robert. So the correct answer is option C, Russell. Russell gave the theory of clay particle. Next question. The relative proportion of sand, silt and clay is called option A, porosity, option B, soil structure, option C, soil texture, option D, plasticity. So the correct option is option C, soil texture. The relative proportion of sand, silt and clay is known as soil texture. Next question, choose the correct statement. Fertilization and irrigation are less frequent in clayey soils than in sandy soil. Maize cannot be grown well in clay soil because the crop requires good aeration. Crops like paddy cannot be grown well in sandy soil. You can look the options. Option A, only one is correct. Option B, 1 and 2 are correct. Option C, 1 and 2 are correct. Option D, all statements are correct. So the correct option is D, all statements are correct. So fertilization and irrigation are less frequent in clay soils than in sandy soil because clay soil can retain more water. Then it can retain more nutrients also. Then maize cannot be grown well in clay soil because maize is a crop that requires good aeration. Then crop like paddy cannot be grown well in sandy soil because we know that paddy is cultivated in wetland condition, that is submerged soil. So in sandy soil it cannot retain water, so we can't grow paddy in sandy soil. So the correct option is all statements are correct. Here all the three statements are correct. The next question, basic property of soil that cannot be changed. Option A, porosity, option B, structure, option C, texture, option D, bulk density. So among the options, which is the basic property of soil that is constant, that cannot be changed. So the correct answer is option C, texture. We cannot change texture. It is a basic property of soil. The next question, which of the following physical property cannot be easily changed? Can be easily changed, sorry, can be easily changed. Option A, correct particle density, option B, porosity, C, bulk density, D, temperature. So here, which among these properties, which can be easily changed? So the correct answer is porosity. We can, option B, porosity. We can change porosity very easily. While particle density, bulk density, temperature, it cannot be easily changed. We can't change particle density, is it? Then next question, factor that mainly influences the soil texture. Option A, climate, option B, parent material, option C, vegetation, option D, time. So among these are the factors of soil formation, and among these factors, which mainly influences the soil texture? That is the question. The answer is option B, parent material. So parent material is one of the main factor that influences the soil texture. Other factors also influences, but mainly parent material influences the soil texture. Next question, skeleton of soil. Option A, sand. Option B, silt. Option C, clay. Option D, both A and B. So which is known as the skeleton of soil? So correct answer is option D. That means both A and B. That means sand and silt. So another name of sand and silt, like collectively sand and silt, is known as skeleton of soil. Then next question, flesh of soil. Option A, sand. Option B, silt. Option C, clay. Option D, both A and B. So what is the answer? Answer is option C, clay. Clay is known as the flesh of soil. So sand and silt are what? Skeleton of soil. while clay is flesh of soil. Next question, widely used system for the classification of soil particles. Option A, ISSS. Option B, IUSSS. Option C, USDA. Option D, all of the above. Correct answer is all of the above. These all the three systems are used for classification of soil particles. Here, according to a different system, different classification of soil particles is present. They made a classification of soil particles into sand, silt, clay, etc. Next question, static property affecting all other soil properties. Option A, soil texture. Option B, structure. Option C, aeration. Option D, temperature. So, among the soil properties, which is a static property, that is, we can't change. Like its meaning is the property which is static. It cannot be changed. So, what is the answer? Obviously, option A, soil texture. So, it is a static property which affect all other soil properties. So, according to the soil texture, soil aeration, soil temperature, all vary. Okay. The next question, analytical procedure for determining sand, silt and clay contents in a soil sample where the particles are separated into various size groups from sand, silt and clay is called. Option A, mechanical analysis. Option B, sieving. Option C, sedimentation. Option D, deflocculation. So, among these options, which is the analytical procedure for determining the sand, silt and clay contents. In that method, we will group particles according to their size. Okay. So, which is the answer? Answer is option A, mechanical analysis. It is an analytical procedure for determining sand, silt and clay contents in a soil sample where the particles are separated into various size groups from sand, silt and clay. Okay. The next question, finer soil particles are quantitatively determined by option A, sieving. Option B, sedimentation. Option C, deflocculation. Option D, pyknometer. So, which is the process for determining the quantity of finer soil particles like clay. So, what is the correct answer? Option B, sedimentation. So, by sedimentation, we will determine finer soil particles like clay quantitatively. We can know, or by using this technique or process, we can know the quantity of finer soil particles from a soil sample. Okay. The next question, depth of cultivated soils. Option A, 5 cm, B, 15 cm, C, 20 cm, D, 30 cm. Option B is correct answer, 15 cm. So, 15 cm, the depth of cultivated soils will be 15 cm. Next, the physical condition of soil in relation to plant growth. Option A, tillage. Option B, zero tillage. Option C, tilth. Option D, minimum tillage. You all know the answer. This is a common question. So, correct option is C, tilth. It is a physical condition. Tilth is a physical condition of soil in relation to plant growth. This is important. In relation to plant growth. So, the physical condition of soil in relation to plant growth is tilth. Okay. Then, next question. The texture can be determined by options: Boyko's hydrometer method, international pipette method, field method, all of the above. So, from these techniques, which technique is used for determining texture? So, correct answer is all of the above. That means Boyko's hydrometer method, international pipette method, field method. These all are the techniques or processes or the devices used for determining the texture. In Boyko's hydrometer method, we will use the device Boyko's hydrometer. In the national pipette method, we will use a pipette. Field method, we will use our hand for determining the texture. Okay. The next question, a method for analyzing soil texture in field condition. Options, sieving method, mechanical analysis, field method, Atterberg apparatus. So under field condition, which is a method for analyzing the soil texture. Correct answer is option field method. Here I am not dividing the options into A, B, C, D. Like you can directly choose from the options. Okay. So option C or field method is the correct answer. Okay. Then next question, mineral particles dash are considered for mechanical analysis. So here the question is the size of mineral particles or the size of soil particle we use or we consider for mechanical analysis. We know the mechanical analysis is a technique or process by which we will determine the texture of the soil. Okay, in that which mineral particles we will consider. So we can look the options. A, less than 2 millimeter, then B, greater than 2 millimeter, C, less than 5 millimeter, D, greater than 3 millimeter. So here the correct option is option A, less than 2 millimeter, 2 mm. Okay, so less than 2 mm, they are actually known as a soil separates. So we will consider the mineral particles of size less than 2 mm diameter for mechanical analysis. The next, widely used dispersing agent in the mechanical analysis. Okay, option A, sodium chloride, that is our NaCl, and B, sodium carbonate, then C, sodium hexametaphosphate, D, sodium bisulfate. So what is the correct option? Which is a widely used dispersing agent. What is a dispersing agent? It is a chemical or agent or reagent used to separate the soil into its individual particles. It will cause dispersion. Okay, so if there is dispersion, um, we can know the quantity of different soil separates. Okay, actually soil particles are cemented by clay, cementing agents, then calcium carbonate, uh, organic matter, etc. So for breaking their bond and separating into the individual particles, we will use what dispersing agent. So here correct option is option C, sodium hexametaphosphate. So this is an important question. Everyone note that this is an important question regarding the JRF, SRF and ASRB net exam. So widely used dispersing agent, it is sodium hexametaphosphate. Okay. Then correct statement regarding mechanical analysis of soil. Organic matter and humus are oxidized with 30% H2O2. Then calcium carbonate and oxides of iron and aluminum are removed by dilute HCl. Soluble salts are removed by filtration with distilled water. Okay, so what is a correct, like from this we can choose the correct statement. So first one, organic matter and humus. What we will do by using 30% H2O2, organic matter and humus are oxidized. Is it? Then calcium carbonate and oxides of iron and aluminum are removed by dilute HCl. This is correct. We will use 30% H2O2 to oxidize organic matter and humus. We don't need organic matter and humus for the mechanical analysis, because here mechanical analysis we will quantitatively determine the soil particles, clay, silt and sand. Okay. So here there no need of organic matter and humus. So what we will do? They will be oxidized to carbon dioxide and water by using 30% H2O2. It is a strong oxidizing agent, H2O2. So not the percentage, like its concentration, 30% of H2O2. Then calcium carbonate and oxides of iron and aluminum are removed by dilute HCl. This is correct option. Then soluble salts like NaCl, calcium chloride, etc. they are removed by filtration with distilled water. We know they are soluble in water. So by using distilled water, it can be removed easily. So what is the correct option? Option C. 1, 2 and 3 are correct. Okay. Next question. According to Stokes' law, the terminal velocity of a spherical particle settling under the influence of gravity in a fluid of a given density and viscosity is option A, directly proportional to the radius, option B, inversely proportional to the radius, option C, directly proportional to the square of radius, option D, inversely proportional to the square of radius. So here this is Stokes' law. Stokes' law states that the terminal velocity of a spherical particle which settles under the influence of gravity in a fluid of a given density and viscosity is dash, which is what is the correct answer? Which is directly proportional, inversely proportional to the radius or square of radius. So here the correct option is directly proportional to the radius square. So terminal velocity V directly proportional to radius square. This you should remember. What you should remember? V directly proportional to radius square. Radius square. Okay. Then next question. Stokes' law is not applicable for particles. Options greater than sand silt. Option B greater than silt size. C greater than clay size. Option D all of the above. So Stokes' law is not applicable to which particles? So option B is correct answer. Greater than silt size. This is the statement which is taken from Fundamentals of Soil Science. So this is very important. Okay. Stokes' law is not applicable to the particles which is greater than silt size. So the particles that is greater than silt size like sand, fine sand, coarse sand, etc. We can't apply Stokes' law to those kind of particles. Okay. So this is an important question. Note it. This is an important question. The assumptions of Stokes' law. What are the assumptions of Stokes' law? First option, particle must be smooth and rigid. Option B, particle must be larger than liquid particle. Option C, must not be affected by the wall of vessel. So when we have any law, it will have assumption, certain assumptions. So Stokes' law assumptions are uh, which are the assumptions of Stokes' law. So correct option is option D, all of the above. Here the particle which is under the consideration, it must be smooth and rigid. It must be smooth and rigid. It is one of the assumption that we took in Stokes' law. Then option B, particle must be larger than liquid particle. So the for example sand, which is, or clay, let's take clay as an example. It is falling in water, like it is a liquid. Water is a liquid of density 1 gram per centimeter cube is it. Okay, so here it is a water. It is falling in water under the influence of gravity. So there will be water molecule. These are the water molecules. So what we assume in the Stokes' law. Stokes' law means the velocity of this particle which falls in a fluid of given density and viscosity, that is V, is directly proportional to it will have a radius, means R. So it is directly proportional to R square. It is a Stokes' law. So the radius of this falling particle, it must be larger than the liquid particle. These are the liquid particles. So liquid particles must be small. Okay. So the particle which falls under the influence of gravity must have enough size which should be greater than the liquid particle. Okay. Next assumption is must not be affected by the wall of vessel. So here the wall of vessel will exert some friction. Okay, frictional force. So if it exerts like that force, the velocity of the particle will be affected. So here the terminal velocity is constant. Okay, that constant velocity is directly proportional to r square. So for sand, it will be different velocity. For silt, it will be different. The velocity of silt will not be same as sand or clay. Okay. So the velocity must not be affected by the wall of vessel, or the particle must not be affected by the wall of vessel. So this is the correct answer, option D, all of the above. So remember these assumptions. These are also important, very important, very important question. The next, match the following. This is the ISSS classification, Indian Society of Soil Science, International Society of Soil Science classification. Coarse sand, fine sand, silt and clay, their respective diameter in millimeter. So what is the correct option? Like when there is one question, this is one of the important question, which is this is one of the previous year question. Okay, so here you should remember that sand is bigger, clay is smaller. Okay, so you can choose from the option. So clay, it is very small. So which is a small thing? This is one, less than 0.02 0.002 millimeter. This is a clay diameter. So coarse sand, it will be greater. Okay, what is greater? Which is greater among the diameter? Option B, 0.2 to 2 millimeter. Okay, then fine sand, it will be 0.02 to 0.2 millimeter. Then silt, it will be middle, like 0.002 to 0.02 millimeter. So this is the correct option. Coarse sand 0.22 to fine sand 0.02 to 0.2 silt silt 0.002 to 0.02 clay 0.002 millimeter. Okay, and this is another classification, USDA classification. So it contains the sand is divided into five different classes. Then silt and clay. Clay, obviously it will be 0.002 millimeter. So this is a correct answer. Please take a screenshot of this and study it well. Very coarse sand will be 1 to 2 millimeter, while clay is less than 0.002 millimeter or 2 micrometer. You can say this is 2 micrometer. 2 micrometer. Okay. Remember this. The next question, average particle diameter of sand. This is a statement from that book. So option A, 2 to 0.05 millimeter. Option B, 2 to 0.02 millimeter. Option C, 2 to 0.25 millimeter. Option D, 2 to 0.1 millimeter. Okay, what is the correct answer? Option A, 2 to 0.05 millimeter is the average particle diameter of sand. Okay, here sand classification comes from 2 millimeter. It ends in 0.05. Okay, so 2 to 0.05. It is the size range of sand. So remember, sand is divided into 5 different classes. Okay. Then next, unsatisfactory physical properties developed in the presence of options sand, silt, clay, sand plus silt. So what is the correct option? Due to which whose presence unsatisfactory physical properties is developed in a soil sample. Option B, silt is correct. So when silt is present in more amount, Unsatisfactory physical properties will be there, like soil texture, soil structure, aeration. It will not be good. Okay, good enough to good for like cultivation or any other activity in the soil. Okay. The next, the most chemically active soil fraction is option sand, option B silt, option C clay, option D both A and B. Okay, what is the correct answer? Which is a what is the question? Most chemically active fraction of soil. So what is the correct answer? Option C. Clay is the correct answer. Clay is the most chemically active soil fraction. The next, aggregation is not possible in option sand, silt, clay, both A and B. Correct answer option both A and B. Sand and silt, in sand and silt dominated soil, aggregation is not possible, while in clay aggregation is possible. Next, unit of viscosity. Option A calorie per gram. Option B millipoise. Megapoise. Option C poise. Option D both B and C. Correct answer option D both A, B and C. These are units of viscosity. What is viscosity? It is the resistance of a liquid to motion, like the sliding over the layers, etc. Okay. The next, property of fluid by the virtue of which it reduces the relative motion among different layers of soil is called. Options: A consistency, B viscosity, C plasticity, D specificity. Option B viscosity is the correct answer. It is a property of fluid by the virtue of which it reduces the relative motion among different layers of fluid. You know the we all know that in fluid different layers will be there. So when viscosity will be higher, motion between or the slipping of different layer will be lesser. Okay. And next question, what is the main advantage of international pipette method for particle size analysis? Option A, it is quick and easy to perform. Option B, it is regarded as a standard method due to its accuracy. Option C, it requires minimal equipment. Option D, it can analyze a large number of samples simultaneously. So which is the correct answer? The question asks for the main advantage of international pipette method. The correct answer is option B. It is regarded as a standard method due to accuracy. So which is the standard method? It is international pipette method. International pipette method is standard because it is very accurate. Okay. The next, most accurate method of soil texture analysis. Option A, Boyko's hydrometer method. Option B, international pipette method. Option C, aggregate method. Option D, all. Correct answer, international pipette method. It is a standard method, okay, because of its accuracy. Then option, next question, which is a rapid method of mechanical analysis. Option A, Boyko's hydrometer method. Option B, international pipette method. Option C, aggregate method. Option D, wet sieving. So here the correct answer is Boyko's hydrometer method. Here we will use a hydrometer. So it is very rapid. But international pipette method will take time. But Boyko's hydrometer is very rapid. But what is the problem of international pipette method? It takes time. But it is a standard method because of its accuracy. So advantage of international pipette method is its accuracy. Advantage of Boyko's hydrometer is it is rapid. Okay. Try to distinguish between the two methods. If you have any doubt regarding this topic, you can watch my video. I have uploaded it. I will share it in the description box. The next question, Boyko's hydrometer method of mechanical analysis cannot be used in option calcareous soil, option B organic soil, option C saline soil, option D all. So here Boyko's hydrometer method we will use a hydrometer. So in which type of soil this method is not suitable? Option D is the correct answer, all soil. Like in calcareous soil, organic soil, and saline soil, we can't use Boyko's hydrometer method. So here we have to treat every soil. In organic soil, we have to remove organic matter. In saline soil, we have to treat, or we have to remove the salinity. Or in calcareous soil, we have to remove the calcium carbonate content. Then only we can do mechanical analysis. We can't do it rapidly. Like suddenly we can't take like a calcareous soil or organic soil or the saline soil and do the Boyko's hydrometer method, because our instrument will get damaged. Okay. The next, the temperature to which hydrometers are calibrated. Options: 10 degrees Celsius. Option B, 20 degrees Celsius. C, 30 degrees Celsius. D, 40 degrees Celsius. Option um, option B is the correct answer. 20 degrees Celsius. So here hydrometer should be calibrated to 20 degrees Celsius for taking reading. Okay. Note this. It's an important question. You should not take a screenshot, or I will share the PDF of these notes. Okay. Then what is the recommended measurement time for silt clay fractions in the hydrometer method? Options: 4 minutes. Option B, 1 minute. Option C, 10 minutes. D, 2 hours. So in hydrometer method, for measuring silt and clay, how much quantity of silt and clay, after how much time we will take the measurement of silt and clay in the when we use hydrometer method. So here options, 4 minutes, it is the correct answer. Option A, 4 minutes is the correct answer. So after 4 minutes we will take, or we will calculate how much silt and clay is present in the by using hydrometer method. The next, what is the recommended measurement time for clay fractions in the hydrometer method? So for silt and clay alone, measurement time will be different. Okay, from this question, from these two questions, you should understand the measurement time for sand plus silt, sorry, silt plus clay, and clay fraction alone will be different. Okay, so here the correct answer is option A, 2 hours. So recommended measurement time for clay fractions in the hydrometer method is 2 hours. The next question, choose the correct formula. Which is the correct formula for converting degree Celsius to Fahrenheit? So B is the correct formula. Degree Fahrenheit is equal to degree Celsius into 9/5 plus 32. And total number of textural classes in textural triangle by ISSS. Option A, 8. Option B, 10. Option C, 12. Option D, 40. What is the correct answer? 12 is the correct answer. Option C. Total number of textural classes in the textural triangle by ISSS is 12. And total number of classification in size group of soil particles by International Society of Soil Science, ISSS. So ISSS divided the soil particles into how many groups? Answer is 4. Into 4 groups, like coarse sand, fine sand, silt, and clay. These are the soil particle, or different classification of soil particles by given by ISSS. And sandy soils are: option A, coarse, textured, and light soil. Option B, coarse, textured, and heavy soil. Option C, fine textured soil, light soil. Then option D, fine textured and heavy soil. So what is the property of sandy soil? Uh, Option A is the correct answer. It is a coarse, textured, and light soil. Okay. And clay soils are same options. What's the correct answer? Option D, fine textured and heavy soil. So this is sandy soil. Coarse, textured, and light soil is sandy soil, and fine textured and heavy soil, it is clay soil. Okay. Amount of sand and clay in sandy soil are dash and dash respectively. In sandy soil, how much sand and clay is present? So see the options: 80%, 10%, 70%, 15%, 80% less than 10%, 70% less than 15%. So here correct answer is option D, 70%, then less than 15%. So 70% sand and Less than 15 percentage clay is present in the sandy soil.